Yeah. Good morning, all. This is myself, Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence in SR University. Today, I'm going to explain data structures concept, that is stack. In last video, I explained what is data structures, types of data structures, right? And what is linear data structure and what is non-linear data structure. So the stack is a linear data structure. Okay, we have some operations in the stack, that is push, pop, peek, and one more is the display operation. Okay, implementation of stack by using arrays and by using linked list. Today I explain this arrays concept. Now here you observe here, data structure is the most fundamental building block concept in computer science. To build a software system, we use data structures, right? So data structure is a particular way of organizing data in a computer so that it can be used effectively. You observe here, a data structure is a collection of elements. These elements are organized in a structure that is called the data structure. Data structure is logical or mathematical organization of data. It describes how to store the data and access data from the memory. Okay, how to store the data? We have to use some operations. So in these operations, okay, push is used for the inserting the elements. Pop is using for the removing the elements from the stack. So and coming to stack, we have two operations. So now the dictionary, this is a dictionary, and this is the one more example is the for the data structure. This is Google Maps, and this is the table. Table means that is a indexing. Okay, now coming to examples of data structures. One is the online movie ticket booking. So now here, railway ticket booking. So the teller use the give the tickets to the people. And next one, music player. We have to follow sequential or structured way. And web browsing also we follow the structured way. Google Map is also example for the data structure. You observe here, online movie ticket booking, railway ticket booking, music player, web browsing, and Google Map. These are all the examples of the data structure. Now, the types of data structure. So observe here, students. Now here we have mainly two types of data structures. One is the built-in data structure. Another one is the user-defined data structure. Built-in data structures, that is a variables like that is in our C programming, we discussed data types. That is called integer data type, float data type, character, boolean. Now these are all the data types in our C programming. Coming to user-defined data structures. This can be categorized into two types. One is linear data structures. Another one is the non-linear data structures. In linear data structures, we have four types of linear data structures are there. One is arrays, stack, queue, and linked list. Arrays, stack, queue, and linked list. Now, these are all the linear data structures. And you observe here, in last video, we discussed the queue concept. This is called the first in, first out manner. Now, queue stack, this is the last in, first out manner. The last element is removed first. And next one is the arrays. I think everyone knows the array concept. Array is a collection of similar data items. These are stored in contiguously. And the very important concept is the linked list. Next video, we will discuss linked list. Okay. And we will discuss the differences between arrays and linked list also. And non-linear data structures, we have two types of non-linear data structures. One is called tree, another one is called graph. Okay. Now trees, we have different types of trees are there. And graphs, we have diagraph and undirected graph. In next videos, we will discuss briefly. is about the data structures. We have two types of data structures: built-in data structure, user-defined data structure. Built-in data structures is nothing but a variables. User-defined data structures can be categorized two types: linear, non-linear. Okay, linear again we have four: arrays, stack, queue, and linked list. Non-linear we have two: trees and graphs. Yeah. Now in linear data structure, the data items are arranged in linear sequence. In linear data structure, data is organized in a linear order. Linear order means that is the sequential order. In non-linear data structure, the data items are not in a sequence. In the non-linear data structure, the data elements are not stored in sequential manner. Rather the elements are hierarchical related. Hierarchical related means that is stored in the tree structured manner. Okay, you observe here in linear data structures, the data is organized linearly. Non-linear data structures, the data is not organized linearly. These the elements are organized in hierarchical. Yeah, now the abstract data type, because we will discuss the stack concept. So the abstract data type is a class that has a defined set of operations and values. Abstract data type is a data type where only behavior is defined, but not implementation. Okay, the behavior, what is the behavior of the structure that is defined in the abstract data type, which allows a programmer to protect and hide implementation of the process and only gives the key to other functions or users. We need to know enough about given function and run, but it don't need to know and what about how the internal structure will be work. These are all sorry, these are all discussed in the abstract data type. Example is a class, array, stack, and queue. Now the coming to our point, stack is a linear data structure. Now, stack is an abstract data type. Stack is a linear data structure which follows a particular order. Operations are performed. Now, the order may be LIFO manner. See, LIFO manner, what is LIFO manner? Last in, first out. Or philo, that is called first in, last out. The first element is removed last, or last element is removed first. This is the order of the stack. Observe here, one is LIFO, or sometimes we are called the philo, that is called F5 yellow. Now the operations of the stack is main two operations are there. One is push operation, another one is the pop operation. Push operation is using for the inserting the elements into the stack, and pop operation is using for the removing elements from the stack. These two operations performed using one entry. We have a only one entry. See here, this is called the one entry point. Now we are inserting the elements here. We are removing the elements from the box. Okay, simple example is the box. In box, we have only one entry. So based on this entry, we are inserting the elements. Based on this entry, we have to remove the elements from the box or elements from the stack. This is also example you observe here. This is the first one. This is second one. This is third, fourth, five, sixth. Okay, now actually we have inserted this cubic in last position, last. So when we remove this first one, then we have to remove all these cubics. After this, we can remove this. After these two, we can remove this. After these three, we can remove this. This is the scenario of the stack. Okay, stack is follow the last in first out. You observe here, last in first out. So last element will be removed first. See now. Yeah. Now the first operations of the stack. See, already we discussed. Okay, 1 second, friends. Yeah. Push operation. Add item. Add an item. See, add an item in the stack. If the stack is full, then it is said to be an overflow condition. Overflow condition means if the stack is we enter the elements into the stack. When the size, that is called the stack variable, we take one variable that I will explain it briefly. That variable is equivalent to size minus one. So there is no possibility to insert a new element into the stack. Okay, this is the push operation. Push operation, we can add items into the stack. If the stack is full, there is no possibility to enter the new element. That is called the stack overflow. And pop. Pop, what do you mean by pop? We remove the elements from the stack. Remove an item from the stack. The items are popped. The items are popped in reverse order in which they are pushed. If the stack is empty, then it is said to be underflow condition. Underflow condition means here we have the position values. You observe these position values. This is the n. Suppose n value equal to 5. We have n value equal to 5. Suppose always you start from the 0 to 0 to 4. 0 to 4 means the number equal to 5. So now initial value equal to top value equal to minus 1. When we are inserting a new element, the top value will be incremented by 1. So minus 1, you observe here, minus 1. So plus plus minus 1. Plus minus 1 equal to 0. So the first element is reside in the 0th position. So 0th position. So this is the first element. And next element, next continue until n minus 1. Now the display operation, this is used to display the values of the stack if the stack is not in underflow condition. Underflow condition means if the top equal to minus 1, your stack is underflow. If top equal to n minus 1, your stack is overflow. Overflow, there is no possibility to insert a new element. Underflow, now there is no elements into the stack. That is called the empty stack. So now coming to the position of top, minus 1 is initially we take the minus 1, so we write like top equal to minus 1. Top equal to minus 1, stack is empty. And we enter only one element, so top value equal to 0. Only one element in the stack. N minus 1, so stack is full. Now stack overflow, top equal to n minus 1, your stack is overflow. In by using the, what is the operation we have? That operation is push operation. So in push operation, top equal to n minus 1, top equal to, where is the top? Yeah. Top equal to n minus 1, there is no possibility to insert a new element. So this is about the basic concept in our stack. Yeah. Now the step 1. What is the step 1? In push operations, the step 1 is check whether the stack is full or not. Whether stack is full or not, top equal to size minus 1. Top equal to size minus 1. So then your stack is full. If it is full, then display stack is full. The insertion is not possible and terminate the function. Step 3, if it is not full, then increment top value by 1 plus. That is called the set stack of top. You have to value top value equal to C value. Stack of top equal to value. So coming to the algorithm of the stack, you observe here, algorithm push of x. X is the element. X is the element. If top equal to n minus 1, stack it top equal to n minus 1. What is n value? I want to write here. See, top equal to minus 1 initially. Top equal to minus 1. Now n value equal to 5. We assume n value equal to 5. If top equal to n minus 1, printf, the stack is full or overflow. Else condition, right? Now stack of, this is the variable stack of plus top equal to x. Plus top equal to x. Okay, now this one. Stack is overflow. Otherwise top equal to top plus 1. stack of top equal to x. So stack of top equal to x is nothing but a stack of plus plus top, or uh, top equal to top plus 1, and stack of plus plus top equal to x. Both are same. So underflow when top equal to minus 1. Top equal to minus 1 means initially we are assigned the top equal to minus 1. If the top equal to minus 1, then there is no element in your stack. Okay, clear? This is the basic function of the push operation. And next one is the pop operation. Okay. Now pop operation, you observe here whether your stack is empty or not. First we have to find out whether your stack is empty. Whether stack is empty. Top equal to minus 1. Top equal to minus 1, your stack is empty. If it is empty, then display you print stack is empty. Deletion is not possible, and terminate the function. Okay. So because there is no elements in your stack, how can we remove the element? Simple logic here. Okay, first top equal to minus 1, there is no elements in the stack. Okay, then how can we delete the elements from the stack? This is the step 2. And step 3, if it is not empty, delete element is not possible. Okay, because top value equal to already minus 1, there is no top minus minus. That is the step 3. Now coming to algorithm, stack is underflow. What is underflow? Stack, there is no elements in the stack. For example, this is your stack, we assume. Now these are all the, this is the 0, 1, 2, sorry, 2, 3, 4, we assume. Now inserting the elements here, removing the elements here, from here. So top equal to what is value? Top equal to minus 1. So if top equal to minus 1, printf, the stack is underflow. Stack is underflow. Otherwise, now x equal to stack of top minus minus, top minus minus. So written x, the deleted element is x. So this is the algorithm for pop operation. First one, top equal to minus 1. So now stack is underflow. Stack is underflow means there is no elements in the stack. Otherwise, we remove the first top value, top element. Top element is, what is the top element here? Top element here, for example, we have, see, this is the 5, 10, 15, 20, 30 we are assumed. Now which is the last element? 30 is the last element. So now last in, first out. Last element, which is the last element? 30 is removed first. So top equal to, now top position will be decrement by 1. Now 4 minus minus. 4 minus minus means 3. Now this is the top position. Okay, this is the basic operation of stack, that is called pop. And next one is the peak operation. Now peak operation means we print the top value. We print the top value. That is called the peak operation. Whether the stack is empty. How can we check whether the stack is empty or not? Simple, top equal to minus 1, your stack is empty. Right? And if it is empty, then display stack is empty and terminate the function. And next, if it is not empty, then define a variable I and initialize with the top display stack of I value and decrement 1 value by 1, I minus minus. So simple. Now when we are write the condition, if top equal to minus 1, so you print the stack is empty. Otherwise, you print the top value. That is called the peak. You print top value, right? This is about the peak operation. And now here we have a small example. Now you look here, stack is empty, top equal to minus 1, stack equal to minus 1, and initially There is no possibility in top because top equal to -1. And next one is we are inserting a new element, so top value will increment by 1. Top value this is first element, so top value is increment 1, push of 10. So top value is now 0. Here top value equal to -1. Here top value equal to 0. Top value equal to 0. Now push off. Now again we are inserting new element that is called 20. So now top value is again incremented by 1. Top equal to top plus 1. So 0 plus plus, so that is called 1. Now this is the top position. And again we are inserting push of 30. So push of 30 means the third element is inserted here. So top equal to top plus 1. Top equal to what is the top value? 1. 1 plus plus is 2. So the third element is residing. 30 is reside in top. So top value equal to 2. So next one again we are inserting 40. You observe here 40. This is the fourth element. So top equal to top plus 1. Top plus 1 means top equal to 2. 2 plus 1 3. So the fourth element is reside in the top. So now this is the push operations. Now here we are inserting 4 elements. One is 10, another one is 20, 30 and 40. So 4 elements are inserted. Next we are going to use the pop operation. So pop operation, simple, you remember when you are remove the element, simple top equal to top minus 1. So stack is empty. When stack is empty, top equal to -1, then stack is empty. Okay, now here we are inserting the elements. 0th element is 10, 1 element is 20, 2 element is 30, and 3 element is 40. So now we have 4 elements are there. So 4 elements. So we are removing the elements. So pop minus minus, pop top value, top minus minus, top minus minus means so now top is at in third position. 3 minus minus, that is 3 minus minus, that is 2. So here if you want to remove these elements, then top equal to top minus 1. Top equal to top minus 1. Top equal to top minus 1. So top position will be decremented by 1. So now what are the applications of the stack? So this is also very important in our computer science. So the expression evaluation is one example, and expression conversion is another example. That is infix to postfix is very important example for the stack, and infix to prefix is also important, and postfix to infix. So prefix to infix, and backtracking. One more is the memory management. These are all the applications of the stack. Expression evaluation is the first one. Now we will see. One second, I want to explain one concept. Yeah. Expression evaluation is the example. So the first example is the expression evaluation. Suppose I have 5 plus 4 minus 2. This is my expression. How can I evaluate? 5 plus 4 minus 2, or some f equal to a plus b into c minus b minus d. Okay, now how many operators and how many operands? In expression evaluation, we check the operators and operands. Operands are A, B, C, and D. Operators are plus, multiplication, minus. So we take the simple calculator. The A value is here. We are substitute some values. 2 plus 3 into 5 minus 1. We assume this is the expression. So we use the simple calculator. Now what is the output? In simple calculator, the output is simple 2 plus 3, 5. 5 into 5, 25 minus 1. 24 is the output. output. In simple calculator, you observe here. Simple calculator. In computer or laptop or your mobile or any scientific calculator, what is the value? Scientific calculator, what is the value? Anyone? Now, in scientific calculator, your computer is always follow the which rule? Any idea? Any idea which rule we are following? That is called BODMAS rule. BODMAS. So here, first you take the priority, multiplication priority, plus priority, and minus priority. See these three priorities. Okay, multiplication priority is higher than plus priority. Plus priority is higher than minus priority. So now we have to take first one multiplication. Where is the multiplication is there? 2 plus 3 into 5 minus 1. So multiplication. What is the multiplication value? 3 into 5. 3 into 5, what is the value? 15. 15 plus 2 minus 1. So next, what is the highest priority? 2. So plus. So 2 plus 15, 17. 17 minus 1. So final value is 16. 16 is the correct answer. This is called the expression evaluation. And next video I will explain the what is infix to postfix and how to evaluate the postfix evaluation in coming video. All right. I think everyone follows this concept, applications of stack. So now the complexity of the time complexity, the push operation, big O of 1, pop operation, big O of 1, and peak operation is also big O of 1. And space complexity is big O of n. So this is the time complexity and space complexity. And real-time applications, undo and redo operations, function call, and expression evaluation, browse back navigation, and string reversal. These are all the real-time examples of real-time applications of the stack. And next, I will explain the program by using the dev C++. 1 second, wait. Yeah, look here. Now, this is the program for stack. In last video, we discussed Q. Now define max 5. So into stack of max and top equal to initially -1. We take the -1 here. And next one is the how many operations we have? 4 operations. One is push operation, pop operation, and next one is the peak operation, and one more is the display operation. So push operation, see here we are inserting the element that is called the item. A top equal to max -1. What is the max value? 5. Okay, stack of 5. Stack of 5. Okay, top value equal to max -1. Max -1 means 5 minus 1, 4. Then there is no possibility to insert a new element. So now top value, what is the top value? -1. So otherwise, okay, that is, this condition is failed. Then go to the else block, top equal to top plus 1. Stack of top equal to item. Now, otherwise we are used the stack of plus plus top also is acceptable. This is also acceptable without this. Without this, this is also acceptable. Now, the element is in previous example, we take some elements, 4 elements are there. Now, 10 is the first element. So, we are insert 10. 10 is assigned to the 0th location. Okay, now, next one is again we are enter the option equal to 1. Then we are inserting the new element. So this is about the push operation. And next one is the function to pop an element. Pop an element means we are removing the element. So that is top equal to -1. Then stack is underflow. There is no possibility to remove the element because there is no elements. So, and otherwise, in our previous example, we have 4 elements are there. So we have a possibility to delete the element from the stack. So now this is not satisfied, then go to the else condition. Popped element stack of top. What is the top value? I think top value equal to 40. That is the fourth position value equal to third position value equal to 40. So 40 is removed. Top value is decremented by 1. Top equal to top -1. This means top equal to top -1. Top equal to top -1. So previous top value equal to 3. 3 minus 1. So this is about the pop operation. And next one is the peak operation. Now the peak operation top equal to -1. So there is no possibility to print the elements because empty. Otherwise you print the top value. Top value already in our previous function, top pop function, we remove the 40 and the element is 30 is available there. So stack of the top stack of 2 equal to 30. So you print the 30. And next one more function is the display function. I think everyone knows the display function. Top equal to -1, stack is empty. Otherwise, stack elements are you print from top to bottom. Top to bottom is you print I value equal to top to I greater than or equal to 0. You decrement the I value. So a stack of 2, what is the value? 30. Now 2 minus 1. So 1 greater than or equal to 0. So stack of 1, 20. Stack of 0, 10. This is about the display operation. And now coming to main function. So we have take the menu driven operations, menu driven program. So push is one, pop, peak and display, and one more is the exit. You enter the choice 1. So then we are insert the elements for through the push operation. And we are removing the elements from the pop operation. We print the top value. We print all the elements. The sixth case, for example, you are enter 5, then your exit. Otherwise, invalid choice. Okay, now this is a simple program for the stack. Okay, I think everyone follows the stack concept by in your next session, next video, we will discuss the linked application also, and one more is the infix to postfix and postfix evaluation. Thank you all. Thanks for your cooperation. Please like these videos. Thank you.